Alrighty guys, we're going to add to our notebooks today about trapezoids and kites. So underneath our parallelograms, this is a different type of quadrilateral. So I'm going to actually put it back at the top here, and we're going to talk about trapezoids, of which we kind of have two special trapezoids, an isosceles trapezoid and a right trapezoid. And then we are also going to talk about kites, which is our last type of quadrilateral. So these are all quadrilaterals. We have 3 branching families, and then in each family you sometimes have special types of those. So there we go. So let's turn to actually page 86, where we have all of our quadrilaterals in one spot, and let's take a look at our trapezoids. So in general, what a trapezoid is something that has just one set of parallel sides. So if we're looking at this here, we have A, B, C, D, and AB would be parallel to CD. Now, parallel does not mean equal. However, what I can do with parallel lines is I can get between them, these two here are like same side interiors, so they would add up to equal 180. And same thing over here, B and C would add up to equal 180. But I can't do like the star with the heart. Like those ones won't, because they're not between parallel lines. The legs of your trapezoid are not parallel, so you can't do those things. Now, another fun thing that we can do with the trapezoid is we can find what's called a median line, or sometimes it's referred to as a mid-segment. So either a mid-segment or a median line. They kind of both mean the same thing. They're lines in the middle. And so, for instance, the line in the middle of a trapezoid would be connecting midpoint to midpoint. So again, I don't necessarily know that the legs of my trapezoid are the same, but if one leg is cut in half and the other is, then this line here is our median or mid-segment line. And we can find the length of that line by doing half the sum of the two bases. And bases are always the parallel sides of your trapezoid. So like this is maybe B1 and this is maybe B2. And it kind of doesn't matter like which one is B1 and which one is B2, but they are the parallel ones. So we want to make sure we have that straight. And then if I am a better type of trapezoid and I'm an isosceles trapezoid, so kind of these two things are properties of all trapezoids, but these 3 things are special to isosceles trapezoids. What makes an isosceles trapezoid isosceles is that the legs or the non-parallel sides are congruent. So non-parallel sides are congruent to each other. So like in this picture here, if I have A, B, C, D, we got parallel, parallel, and then congruent, congruent. Okay, so we could say that AD is equal to BC, or congruent to, but that helps me write equations and fun things like that. Also, my favorite things about any quadrilateral are the fun facts about a diagonal. So if I draw a diagonal in an isosceles trapezoid, it is fully congruent to the other diagonal. So kind of like a rectangle. AC, the whole diagonal, is congruent to BD, the other whole diagonal. So like, just to be super clear here, this whole thing is congruent to this whole thing. Now, I think it's obvious, but I'm just going to say it in case. Like, it does not bisect. Like, this is not the same length as that. And I think you can kind of even see that in my really bad drawing right here. However, I feel like, I mean, these two triangles would probably be the same. And these two triangles would probably be similar to each other, like proportionally. I feel like that's probably the case because like these are vertical angles. And like these are both small and those are both long. So I feel like I have a side angle side thing going on where these two triangles would be the same. And then the top triangle, bottom triangle here also have vertical angles going on. But these are definitely shorter than those. So that's why I'm thinking like they're probably similar by some amount. Who knows? Like maybe by 2 or by 4. I don't know. Just depends on the trapezoid. And I'm further encouraged by that fact because also in an isosceles trapezoid, because the legs are the same, base angles will also be the same. That was true for our isosceles triangle. So when I have my isosceles trapezoid, ABCD, not only are the legs the same, but the base angles are the same. So again, because the parallel sides are the bases, if I'm thinking about base 1, these base angles are the same as each other. So like angle A would be equal to angle B. And the other base angles are equal to each other, but not necessarily the same as the first, because if all the angles were the same, then I would just be a rectangle. And so angle D is the same as angle C. Now, what I could do though with like A and D and B and C is I can still add those up to equal 180 because it is still between parallel lines and their same interior angles, but that's another fun fact. Now I also should have added on here too, although I would have needed like a longer one. I don't know. We also maybe want to note that we do have right trapezoids. And what a right trapezoid looks like is kind of like a doorstop, I guess. You have like your parallel sides here. And then one of the base angles is 90. But because of the same side interior between these parallel lines, this one would also be 90. So like they always have two 90-degree angles in there. And the reason that I want to bring it up is because once you have something like that, you can do some potential splitting of shapes. So like I could draw this little dashed line right here, and then I might have a rectangle or square with a right triangle going on. So like on one side I have the rectangle or square, depending on if all the sides are the same or if opposite sides are the same. And then over here I also have a right triangle because if I drop this down, then that's also 90. And having that right triangle allows me to do lots of things, like Pythagorean theorem things, or maybe special right triangle things, or maybe sine, cosine, or tangent things. So like we just want to keep that in mind. Like I might be able to do an a squared plus b squared equals c squared thing here, or other stuff. Now, the last one that we have is actually underneath this, and the label is not drawn on there for you. So we're going to write on the side of that, this is our kite. Our very last quadrilateral. And a kite is a kite because it has no sets of parallel sides. However, two pairs of adjacent sides are congruent. So like these two are the same and these two are the same. So that's kind of what makes a kite is that we have two pairs of adjacent congruent sides, but no parallel lines, no parallels. Now, the other interesting thing that you can start doing is putting diagonals in. So like if I put the long diagonal in, you kind of get these two congruent triangles here. So we have one pair of opposite congruent angles. So if I name this cute little kite, actually, let's go back to this one, cute little kite, A, B, C, D. I could say that AB is equal to AD, so these two, or BC is equal to CD. Again, if I draw the long diagonal in, and one will always be longer and one will always be shorter, because if not, then it would be a rectangle if the diagonals were the same length, or it would be a square. So one pair of opposite congruent angles with the long diagonal. And again, if we name this guy A, B, C, D, if I draw that long diagonal in, I have that one pair of opposite congruent angles. So angle B equals angle D. Again, because I really have two congruent triangles right here by side, side, side. So like splitting the two adjacent congruent sides gets you those two congruent triangles. Now also, when you draw both diagonals in there, much like a rhombus, oh my God, that was terrible. The diagonals are perpendicular to each other. So, and rhombus also does that, and square also does that. So that's kind of a fun fact. And that does get me two pairs of congruent right triangles, because we have like, oh shoot, I'm throwing markers at myself. We have this right triangle right here that is congruent to the one right below it. And then I also have these two right triangles on this side that are congruent to each other, but not to the first. And again, when I have right triangles, I'm thinking a squared plus b squared equals c squared potentially. I'm thinking 30, 60, 90, or 45, 45, 90 potentially, or maybe a trig thing potentially. Which the extra fun things, I mean, we kind of already talked about the extra fun things I can think of off the top of my head is just getting your two congruent triangles by side, 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 or the four congruent right triangle, or not four, two pairs of congruent right triangles like we did up here. So, I mean, I guess I already spoiled that, but there you go. So these are all the different properties that we can use. And guys, in a separate video, I'm going to do a whole bunch of practice problems with trapezoids and kites. So see you there.